Hello friends, I am Amit Belikar from Tips and Tricks by A and B welcomes you to my channel. First let's have a look what we are going to deal in this presentation. Want to know why this material breaks so easily? Then don't skip any part of this video and stay tuned. But before moving further, if you still didn't subscribe to my channel, please click on subscribe button and click on bell icon to get notifications of all my new videos. In this presentation, we are discussing about factors affecting size reduction. After going through this presentation, the learner will be able to describe factors affecting size reduction. First, we will enlist factors affecting size reduction. Factors affecting size reduction are as follows: hardness, toughness, stickiness, abrasiveness, moisture content, material structure, purity required, softening temperature, ratio of feed size to product size, physiological effect, bulk density. Now let's discuss these factors one by one. First factor is hardness. It is a surface property of the material. The harder the material, the more difficult it is to reduce in size. Thus, it is easy to break soft material to a small size than hard material. But if a hard material is brittle also, then size reduction may present no special problems. Next factor is toughness. Toughness of a material is sometimes more important than hardness. A soft but tough material may present more problems in size reduction than a hard but brittle substance. For example, it is difficult to break rubber than a chalk. In pharmaceutical material, fibrous drugs are tougher because of its moisture content. For some materials, toughness can be reduced by treating the material with a liquefied gas like liquid nitrogen or cooling the substances to temperatures lower than -100 to -150 degrees Celsius, making them brittle. Another factor is stickiness. Stickiness is a property that causes considerable difficulty in size reduction. If material adhere to the grinding surfaces or the meshes, screen may be choked. If the method used for size reduction produces heat, then size reduction of gummy or resinous substances may create problem in size reduction. Next is abrasiveness. Some substances are tough enough to wear away the surfaces of the machine. It is called as abrasive property. For size reduction of such material, machinery should be properly selected. During the grinding of some very abrasive substances, the final powder may be contaminated with more than 0.1% of metal worn from the grinding mill. Another factor is moisture content. Moisture content in the material influences various properties like hardness, toughness, or stickiness. Thus, moisture content creates a problem in size reduction. Thus, material should be either dry or wet for easy size reduction. It should not be damp. Usually, less than 5% of moisture is suitable if the substance is to be ground is dry, or more than 50% if it is being subjected to wet grinding. Another factor is material structure. Some substances are homogeneous in character, but majority have some special structures which may create problem in size reduction. For example, mineral substances may have lines of weakness lead to form flake-like particles, while vegetable drugs have a cellular structure often leading to long fibrous particles. Next is purity required. Certain type of size reduction apparatus cause the grinding surfaces to wear. Thus, impurities enter in the powder. Such methods must be avoided if a high degree of purity of product is needed. Cleaning of machines in between batches is necessary to maintain purity of the powder. Thus, machines which are difficult to clean should be avoided to maintain purity. Next factor is softening temperature. During size reduction process, sometimes heat is generated which may make some substances soft. The temperature at which this occurs is very important. For example, waxy substances such as stearic acid, drugs containing oil or fats. Some methods can be used to overcome this, like cooling the mill by water or air. It can also be achieved by using liquid nitrogen. Another factor is ratio of feed size to product size. To get a fine powder in a mill, it is necessary to use a small feed size for size reduction. Hence, to get fine powder, process of size reduction should be carried out in several stages with different equipments. For example, preliminary crushing followed by coarse grinding and then fine grinding. Another factor is physiological effect. Some substances are very potent. During their particle size reduction, dust is produced. Small amount of such dust may produce an effect on the operator. So it is dangerous for the worker. To avoid this, enclosed mills must be used or wet grinding should be done if possible. Last factor is bulk density. Output of size reduction of material in most of the machines depends upon bulk density of material. Now let's summarize today's session. In this session, we had discussed various factors affecting size reduction as hardness, toughness, stickiness, abrasiveness, moisture content, material structure, purity required, softening temperature, ratio of feed size to product size, physiological effect, and bulk density. We discussed how these factors are important and should be considered during size reduction process. Thank you for your patient listening. If you like this presentation, please click on subscribe button and bell icon to get notifications of further videos. Like it and share it to your dear ones. Drop your queries in comments or on my mail address which is given in the video. Thank you once again.